Thank you again, and feel welcome to this lesson today, which I want us to go through collinearity. And to demonstrate this concept of collinearity, I'll provide an example, and then using that example, I believe that we will be able to understand how to work on problem related to collinearity. Consider this example one, which says that show that the points A, B, and C with the given coordinates are collinear. Now, to proceed with this one, we first of all need to form two vectors. We need to form two vectors, and the vectors that I want to form for this case, I'll form vector 1 to be AB, which simply means B minus A. So if I want to get this vector AB, I'll take B minus A, which will be B4, 12, 20 as a column vector, and then A will be 1, 3, 5. By subtracting the two, I'm getting 3, 9, 15. Then I'll form the second vector, which is SC. The same way, it will be C minus A. That is 3, 9, 15 minus 1, 3, 5. And subtracting this one again, I obtained 2, 6, 10 as a column vector. Now, the second step, or the first thing that I need to do here, is first of all to show that the two vectors formed, that is AB and AC, are indeed parallel. And to show that, we need to show that vector AB is a multiple of AC by a constant K. So our task here is to find this constant K. And by so doing, I'll substitute the values of AB and AC and then solve for constant K. So I'm going to substitute AB, which you obtained as 3, 9, 12, then is equals to K. SC, we got it to be 2, 6, 10. This implies that 3, 9, 15, which is vector AB, is equals to, I'm now distributing this K into the bracket, which now goes to 2K, 6K, and 10K, as we see it here. Once we do that, then I'm going to equate each part of the K. For example, you can see here that this means 2K, this side, 2K is equals to 3, which implies K is equals to 3 over 2. Similarly, I'll also equate the second one, which is 6K equals to 9, which also implies that K equals to 3 over 2. Then lastly, I'll also show that 10K here equals to 15, which simply means that K is equals to 3 over 2. Once I've gotten that, notice that K has the same value. That is, K is equals to 3 over 2. And if you find that K has the same value, then proceed on to write that equation, or the other equation we had here, that AB equals to K SC. But for this case, realize that our K is 3 over 2. Then I'll substitute it here, and I write it as AB equals to 3 over 2 SC. So see that if I want to get this vector AB, then I'm going to take vector AC multiplied by 3 over 2. And therefore, it is clearly that AB is a multiple of AC by a constant 3, 2. And therefore, we conclude that AB is parallel to AC, that is, vector AB and AC are parallel. Once we show that AB and AC are parallel, then we need also to show that they share a common point. By look of this vector up here, you can see that vector AB and vector AC shares a common point A. And since they share a common point A, then we can therefore conclude that the 3 points, that is A, B, and C are collinear. So anytime you want to show that 2 or 3 points are collinear, then you ought to show that you need first of all to form two vectors and then show that those two vectors are parallel, and then proceed to show that those two vectors share a common point. And if they meet those two conditions, then you can therefore conclude that the 3 given points lies on the straight line, or they are collinear. Consider this second example, that you are given two vectors. You are given two vectors OM, which is 3 over 4A, plus a quarter B. And the other one is ON, which is a half A, plus 3 over 2B. So they are saying show that the two vectors are collinear. So we'll proceed again under the solution. We'll let OM to be a multiple of ON by a constant K, and we'll proceed on to find this constant K. This implies, therefore, I'll substitute OM, which is 3 over 4A, plus a quarter B, which equals to K, into ON, which is a half A, plus 3 over 2B. Now, once I've done that, then I'm going to compare the coefficient of A. Let me start by comparing the coefficient of A. We get that 3 over 4 equals to a half K. I'm only comparing the coefficient of A on both sides. Like the coefficient of A here is a half K, and the coefficient of A here is 3 over 4. By so doing, you get that K equals to a 3 over 2. Similarly, comparing the coefficient of B, we have a quarter here equals to a 3 over 2 K, 3 over 2K. And if you simplify that one, you'll therefore get that K equals to a sixth. That is, K equals to 1 over 6. Realize that the two values of K are not similar. The two values of K are not similar, and therefore we conclude that OM is not parallel to ON. And because OM is not parallel to ON, therefore it tells you that those two given vectors here are not collinear. Remember this, that if two vectors are supposed to be collinear, then number one, they need to be parallel, and number two, they need to share a common point. If they meet those two conditions, then conclude that the two vectors are collinear. If they don't, then conclude that the two vectors are not collinear. I believe those two examples have actually enabled you to understand more on the issue of collinearity, and I believe you can subscribe for more interesting lesson to follow. Follow me for more lesson, and I appreciate for your time. Thank you and be blessed.